Hello everyone, welcome back to my channel. In this video, we are going to understand the t-test analysis, not just how to do it in GraphPad Prism, but also when and why to use each type. I will walk you through the basic concepts of t-test, like what is the difference between paired versus unpaired t-test, what is the difference between one-tail and two-tail t-test, and when to use that. To make it easier, I have created a small decision making table which we will use to figure it out which test fits to your data and to your hypothesis and how to decide which test you need to perform. Then we will go into the GraphPad Prism and I will show you how to actually perform each test step by step with the representative example. Also, I will show you how to present your results in the graph format with the representation like a mean plus or minus a standard error of mean with the p-value and the proper formatting. So let's start. So before you apply the t-test analysis on your data, first you need to understand the basic concepts like how your data has been collected and how it and what you are going to measure. So you need to understand what is the difference between paired t-test versus unpaired t-test, one-tail t-test and two-tail t-test. So in briefly, first we will understand these four concepts. Without understanding these concepts, you will be not able to apply the t-test correctly. So first, students t-test assume that in your two set of data, suppose we have a set of data before and after measurement, your variance is equal, so there is no significant difference between the standard deviation of these two set of data. So for that we will also see how to check that one in the GraphPad Prism. Okay, so for like in brief, if I will explain, suppose before versus after, here it can be anything. Just to explain for the uniformity, I am taking this is the before measurement, this is the after measurement for the patient. Before versus after has been done on the same group of patients. Suppose this is the 10 subject. So before measurement is done on that, and after that the same measurement is done on the same subject. Then it is the pair t-test is used because both the results are coming from the same set of subject. Now suppose different set of groups are used. Suppose 10 subject for this before analysis and 10 subject for the after analysis, then unpaired t-test is used. Now suppose in this two set of data, you are just expecting that any change either in the before or either in the set of after, then you are going to use two-tailed. Now suppose you are expecting that the after treatment group should show either decrease or increase only, then you are going to use one-tail. Okay, so this basic concept you should be knowing, then only you can you will be able to apply the t-test correctly. So as we go in the tutorial ahead, I will also explain in detail, and for all the analysis we will draw such type of graphs. Okay, so first I'm going to explain you paired two-tail. Okay, so we have the two set of data before and after. So we have 10 subject. So 10 subjects, this is the blood glucose level measurement. So before like any treatment, for all the patients the blood glucose level was measured, so that is the before reading. Now the patient were given the some treatment like a 2-day treatment or the 1-week treatment, and after that the blood glucose was measured. The subjects are the same. Then this is the whatever the result came, this is the after measurement. So here same patient is used, so this data is paired. So this is the pair test. And now here we are interested in, is there any change between before and after treatment? So we are just expecting that, is there any change, like expect any change. So it will be the two tail. So now we are sure that what we have to analyze. See, our test is paired t-test and two tail. So now let's make the new file in GraphPad Prism, new project. So you have to choose column, create. Okay, I'm going to save. Okay, let me copy paste directly this data before and after. Okay, now I will rename as paired two-tailed, right? So now here first, before we go to the complete analysis, I want to show you that how to see that whether their standard deviation are same or not. Okay, so first you have to select this one, go to an analysis, go to column analysis, t-test. Okay, you have to select both column data set A and B, then okay, then unpaired t-test. Here choose test, unpaired t-test, option two tailed. Okay, okay, now here the one tabular result comes, right? Here if you go down F test to compare the variance, here in last line if you see significant difference at p less than 0.05, no. So there is no significant difference between their variance. So there this test tells that there is no significant difference between their variance, so they have the same standard deviation. So our data can be used for the students t-test. Okay, so first test we have done that, that our both data sets standard deviation is equal. Okay, so I will delete this one. So for all t-tests you have to perform first this one, whether they have the different variance or the same variance. Okay, so this we have data. Now let's apply paired two-tail t-test. So go to analysis, t-test and paired, then two-tailed. Okay, this we do not want. Okay, after minus before, so I'm putting before minus after, so it should come in the minus. Okay, so now this is in the result section. We got the results of our test analysis, pair t-test analysis. Here we can see p-value less than 0.000001, and it is showing significant difference. Yes, so both set of data before and after has the significant difference. Okay, at the with the pair two-tailed analysis. Okay, so now let's see how to represent this in a graph form. Okay, this is our result. Now select the data set, insert new graph of existing data. Now yeah, select this one, mean with standard error of mean. Okay, so we got this data. Now let's put the y-axis glucose level. We do not want x-axis, right? Now let's do the slightly formatting. I will change the thickness of the x-axis in the frame, suppose 1.5. Change the font of the x-axis the regular 11 apply regular 11 apply. Okay, now let's change the color. Okay, so in graph, this thick line, you can see this is the mean, and this is the plus or minus standard error of mean, and this is the individual data. Okay, so now let's go to our result. So what result is saying? P-value summary, this is the significant difference. So we will paste this result 4 star. Okay, so you have to come here, manually add the line, right, 4 star. So it is showing the this way you can show the significance difference, like, so whatever the result comes in your result table. Okay, now this we have plot in a scatter plot. Now let's plot in a bar graph, same result. Okay, again insert new graph of the existing data. Now mean with the standard error, let's column. Okay, let's change the color. Let's change the border thickness 2.14, slightly darker color. Apply for A, for B same 1/4, slightly darker color. Apply. Okay, y-axis will be glucose level. Okay, we do not want x-axis. Now let's apply our significance bar manually. Right, so this way you can present your data in a bar graph format. Now let's put it in a layout form. Let me choose first this graph, then this one. Okay, this way you can present this one, and also like in the previously shown figure, you can put the caption as well. You can take these images, export your images in the PPT, and you can put caption there also. And just for the showing purpose, I'm putting caption here, before and after treatment. N equal to 10, mean plus or minus a significance reduction was observed after treatment. P, now we have to see in the result, P value less than 0.0001. Pair totality is indicating the treatment has a statistically significant effect. So based on result, based on your data, you can modify this one. I just show you the one example, 0.000, right? Right, this way. Now this is the one set of example. Now let's take the different set. Okay, so we saw paired two test. Now let's take the example of unpaired two tail. Okay, unpaired two tail. So as the name suggests unpaired, so both set of data has been collected from different set of subjects. So suppose this is the placebo group has been collected from the 10 subjects, and suppose this is the treatment group, treatment at 50 mg per kg dose has been collected from the another 10 subjects. So both has the different set of subject, hence it will be the unpaired. And here also we are interested in knowing that whether there is a difference between placebo and treatment, so we expect any change, so it will be the two-tailed. Okay, now let's apply the t-test on this data. So the data will be the same because I have taken I kept the all data consistent in all 4 examples. So we will just make it duplicate. I will rename it unpaired two-tail. Okay, so I will just change the name. Placebo and treatment, right? Placebo and treatment. Now let's apply analysis, t-test and paired. We are doing the unpaired t-test. Here also you have to select unpaired t-test and two-tailed. Okay, two-tailed, we do not want this graph, so everything is as it is. So this is our result of unpaired. Now you can see that in the previous result we have seen there is a significant difference, yes, while in this test we are saying there is no significance different. So you can understand that how it is important to select whether your test is paired or the unpaired, because it will give the totally different result. So it is very important to design your study, whether you are doing the paired study or the unpaired study, it will give the totally different result. So the same set of data, if we are analyzing under the unpaired t-test, it is giving known significance. Okay, so for this also graph representation will be the same, because we are same data is there, we are showing the mean plus or minus standard error of mean, so both graph will be the same. So here if I want to present particularly this result, I have to apply NS, known significance. So instead of this, I will apply NS, right? Known significance. So in the layout also we can see known significance, and here accordingly we have to change that we have to change this conclusion that a significance reduction was not observed between the placebo and the treatment at the p-value of this. That way you can formulate and you can write. So by these 2 examples you would have understand that how important it is to choose the correct test type. Okay, now let's take the third example. Third example is paired one-tail. Now we are seeing in this both example we saw the two-tailed. Now let's take the one-tailed. So paired one-tail, and in another last example unpaired one-tail. So paired one-tail. So one-tail, now you already understand what is the pairing. Now one-tail, so here what we are interested in, the after treatment group expect to show the lower blood glucose. So we are only interested in showing that whether after group is showing reduction or not. So expect a decrease or increase only, so it is the one-tailed. So in this case, with this hypothesis we will apply the paired one-tail. Paired because it is done on the same set of subjects. So let's So I will copy this one again. So paired one-tailed, right, before and after. So let's select this data set, go to analyze t-test. This is the paired one in this one-tailed. So from here you have to choose one tail. We do not want this graph, or other things are as it is. Okay, so now here it is showing that there is a difference or significance. So it is showing the yes. So we will change this one in our graph. So the difference are significance, right? And we can write in our graph like this one. So paired one-tailed t-test showing the statistical significance effect. Okay, this way you can represent. So this was the paired one-tailed. Now let's take the example of unpaired one-tail. Now the unpaired word signifies that we have the two different set of subjects. Okay, and one-tail, because we are only interested in seeing that whether the treatment group is showing increase or decrease. So here we are interested in showing the treatment group is showing decrease. Okay, treatment. So I will copy this sheet. So this will be unpaired one-tailed, right, placebo and treatment, right? Now same way you have to choose analysis t-test. Okay, this is the unpaired, so it is unpaired. Here you have to be careful, don't choose the Welch test, choose the unpaired t-test, because our population has the same standard deviation which we had already checked. Now it is the one-tailed, so here one-tailed we have to choose. Okay, so this is showing the significance different, yes, but you can see that p-value is near to 0.05, so it is showing p-value summary 1 star. If there is a more significantly different, then it would have been saying 2 star, 3 star, 4 star, right? So we will represent this in our graphical representation. So here we will change this one, in this also we will change this one. In layout it will automatically change, and accordingly here we will change the description of the p-value and what exactly test we had already used for the analysis. So this way you can represent your data. Now this old test, we assume that for both set of data our standard deviation is similar, our variation is similar. But what if our standard deviation is not similar? Then you have to use the Welch test. So what you have to do, just I will so suppose I am choosing this one, t-test. Okay, unpaired Welch test, do not assume equal standard deviation. Okay, here also you can use either one tail or the two tail. For representation I am choosing two tail. Okay, so this way it will give its own result, where it is assuming that our standard deviation is not similar for the both both set of data. So for this also, similar to this one, you can show the graphical representation and you can write the summary. So by this 5 example you would have understand how to analyze your data for the t-test analysis, and how important it is to select right test, whether it is paired paired or the unpaired or the one tail or the two tail. So if you refer this decision table, like uh, how to make the, in which scenario which test to be used, first you have to check the whether their your variance are, or standard deviation are different or not. So based on this you can use this one, whether so under each scenario there is a condition is given and what test you can. So it will be easy for you to decide and to correct your t-test analysis. I hope this would have helped you. Thank you.